Alright, so today what we're gonna do is, gosh, I'm not sure, we might just actually get through all these parts this semester. Instead of giving you a part print, I'm gonna give you a program and a part. You're gonna work reverse now. So, here's your program. And there's a link for it already in the, module. So in module 6. And so what I've got for module 6 basically says, that's a bad description. It's probably still a good download, but yeah, still downloads, but I'm gonna change that real quick just so it doesn't look all janky. No, it's right there. I don't know why it shows up with the, all right, I'm just gonna change it. I'm gonna delete it real quick and start over. Oh, I know why it's like that. Got an extra 0 in there. It's got an extra O in there. Is what it's got. There we go. Now it should. It wouldn't change. It's still the same download. It just
Don't have 2 downloads in the same?
doesn't have 2 downloads in it. So use the attached program and sample part to create your own. Use probing for this part. See the link. Okay, so Haas has already done a really fantastic video, and actually they've got a couple of really good videos on probing. I'll pull up the program itself, and what I want to do is just kind of go through a few things on it. Okay, so here's the program, and so with this part, it's program number 800. It's going to be an 1.5 inch dovetail with a Y-axis slot. So that tells you automatically, by looking at the part, that how does the part go in the vise or in the machine.
Got a Y slot.
It's got a Y-axis slot, right? So that means that it has to go in this direction. It's got to go like this, facing Y-axis in the machine. Okay. You don't want to put the part in this way because it would actually still create the exact same thing. The slot would be going in the X-axis. So the outside of this part really doesn't matter. The whole point on this project is to get used to making dovetails because dovetails are how we hold lots of other parts. I'll go grab a dovetail real quick so you can see.
Like in the drawer.
Right, similar to that, yeah.
Where you at this morning?
I have no clue.
Oh, I see the smoke. You're cranking out something already, aren't you? Your brain's working on this.
No, for some reason, here, let me refresh.
Yeah, you have to refresh it, 'cause it
So our
doesn't
next
come up.
2nd 8 weeks, I want to primarily use this as our holding method. So you'll still use the vise some, but you'll make blanks like this. You put them in here like this. And then you tighten these 2 bolts in there, okay? So this has a locating diameter on the table. So once it knows where it's at, once you set this, all your parts will always go into this exact same spot. Same X, same Y, same Z, always. So once they're in there. So what I had, they've got a pin that goes in here too for orientation this way. So I had students a couple semesters ago, they bored this hole in the table and then they drilled and reamed this hole in the table, and almost all of them did it wrong. So some of them have bushings in them. Some of them you'll have to set down in there and indicate in. Some of them you'll be able to just drop in and they'll be perfect. But you're gonna have to double check every single machine because everybody, I said, you gotta bore this hole, not ream this hole. Well, if you ream the hole, you gotta ream the hole really slow. Well, they were using Fusion, and so they used all the factory speeds and feeds that Fusion gave, not looking at it, even though I tell them all the time, please don't go by the defaults. You need to set your own speeds and feeds. It's, it goes in one ear, out the other, and everybody blew out their angle hole. And so that means that when they put them on, the part was sitting like this, or like this, or like that. And so we had to make some adjustments, and some of them we made some bushings and fixed them. Some of them are just off. So anyways, once this is down and square and straight, X, Y, and Z is always in this spot. So this just makes repetitive stuff. And why you're doing this is because when you get to multi-axis stuff, is that will hold 80% of the parts is in a dovetail, or pretty much in a dovetail. Be about it. So the top of this print or part, it says X0 and Y0 are in the center of the part. We're going to use probing for that. We're going to use a probe cycle to do X and Y. And then Z is on the top of the stock, Z. I'm not so concerned about this. I'm not so concerned about this. I'm really concerned about, is this a good flat face? Is this face to this face within tolerance? You get about a thou. It really needs to be, this is about 1/8 of an inch. Really 1/24 is perfect because it'll draw this down onto it. So it'll pull it down into it. The more it pulls it down, the tighter it gets, the better the grip.
You said 124, what do you mean?
124 thousandths.
That's 0.124.
0.124, yeah, so it's just a thou short of 1/8 of an inch.
Okay, so we're gonna probe, and then we're gonna run the part. But we're working backwards.
Yeah, did you hear the other things that I just said?
I tried.
I felt like you were doing something different as I was talking.
Download wasn't working.
Okay.
Download working now.
Okay. So, yeah, I'm gonna show you the video, and then we'll go out and we'll do some probing. So X0 and Y0 are in the middle of the part. Z0 is on the top of the part. The tools are 432, 3-inch shell mill, 1/4-inch carbide end mill, 2 flute, and then a dovetail. The dovetail end mill. And now on the dovetail end mill, I'll go grab one. So I want you, it's important on how you calculate it.
They're writing some things down over there.
I got it.
Must be nice. Got a brain like a steel trap.
Yeah, until it comes to the bookwork.
So what?
It comes to the bookwork. I can go out and run anything you want, but once I have to do bookwork on it, I won't have a clue. Like literally, it wasn't showing up as a text. It's showing up as an NC. So I just literally redid it in Word and put it as a text. So I can run this thing right now.
And I'm the opposite. I had all my stuff done, except for the hands-on stuff.
So it says specifically what end mill that you're supposed to use. You got to use that end mill. It's got to be one of these Raptor end mills. Now, not that this is the only kind of end mill that can make a dovetail, but it is the particular dovetail that works with this diameter comp. So when you set a tool like this, you don't actually measure the outside edge of it. You measure the length of it as normal. And then you're going to put 670 in as diameter for the diameter of the tool. It's actually 750 at the outside edges, but at the undercut area, this lower area right here, it's 670.
That's the
0.67.
0.670 is the work comp.
Yes, that's going to be your diameter.
Okay.
Yeah. Because what it does, and I'll let you guys see this, when it goes around, it cuts the dovetail and the outside edges of the part at the same time. So you got to go through and get those two things together. Generally, this is really about the only time that I actually make this part like this. Normally what I'll do, if I can, I will use this end mill to face the top of this and create the dovetail step, because then I don't have to worry about getting those two tools in line with each other. So if I go down from 0, 124 thousandths with the same tool, I know I go down 124 thousandths. If I have a 3-inch shell mill and then a couple of different end mills and tools, there can be a variation of a thou or so as I go. This for me, when I'm making them, I'll come through and just do this and this at the same time. So now the 1/8 inch end mill, it's going to come through here. You're going to set normal cutter compensation for it. So it's quarter inch, sorry. 1/4 inch end mill, regular, you'll just do your regular diameter compensation for that. So you'll just put in the diameter. Not all dovetails will have this y-axis slot that goes through it. This happens to have this pin in it, and that's why it just locates y or x. So you've got this locating y, you got this locating x. So that means no matter how many times I try to put this part in wrong, it really only goes in one way. I mean, you could really try to do it wrong, but you're gonna have to work to do it wrong. So I've got these end mills to use. These are carbides. And then the 1/4 inch end mill, I don't really care if it's a carbide or not that you use, but I have carbides for you to use.
When we put it in there, we're gonna put it in just like that and then run the other side?
No, you're gonna be running this in a vise today.
Okay.
You're just prepping parts for future usage.
Okay.
Yeah.
So that's what we're gonna make that part, and we're gonna make sure it's to tolerance. Put it in there and make sure, right?
Yes.
So if you flew like normal in mills and come out to 6,400 RPM and 64, like feed per minute, do you still feed the same with the ball mount, or does it change because of the ball mount? If it's slower.
Oh, no, I mean, it will have a little more contact in it because it's radial on there. But for what you're doing, I don't think it's gonna make any difference.
I mean, it's just like
Yeah, yeah, tool 3, you got your tool 3 there. Okay, so let's just talk about a couple of codes as we go. What does M6T4 tell me to do?
What? M64?
Nope.
Tool to T4.
Yes. Tool change to tool 4. What work offset are we using on this part?
85.
What is this F50 on there? Feed rate. Feed rate, and how is the feed rate measured? Is it measured yards per year? Percent, inches per hour, inches per minute. Yep. So feed rate for the mill is primarily indicated by inches per minute. Now the lathe is different. It's inches per what?
Lathe, inches per revolution.
What do you say? Revolution, inches per revolution. So IPM and IPR. Okay, what is this line, G1, G41, D3 telling me?
Where to move not the piece, but the tool. The spindle. Spindle, yeah.
So it does do that.
Which line are we working on?
I'm on the 1/4 inch end mill. And there's a line, after the tool change, it's about the 6th line down.
What is it?
G1, G41, D3, X, 0.134. So on that line, you have a G1 move, right? That's feed move.
G1, G41 is the move, right?
What?
G1, 01, G41 are both movements, right?
Well, G1 is a feed move. G41 is cutter compensation on to the left. Okay, so that's how you know that this program is using cutter comp. So you'll see G41 and D3 used on the same line. The D is just your tool number. It doesn't have anything to do with size. Okay, so when you see a tool or a job description where it says this job uses cutter comp on tool 5, you should be able to go D5 arrow down and find a D5 somewhere on that part program, and that's your diameter compensation for that.
That's the same thing down here on 6 lines down also.
So G41 is your cutter comp.
G41 is your cutter comp onto the left side. Now G40, if you look down, so you've got an X move, then a Y move, then another X move, and then you have a G40 line on that line. G40 code on that line. That turns cutter compensation off.
That's when we're gonna go to the end mill.
No, you're still in an end mill.
Okay.
So what you're gonna do is you're gonna cut up one side of it with cutter comp on. Cutter comp doesn't work in Z moves, or we primarily, let me say it like this, we primarily don't do Z moves with cutter compensation on. Because it has a likelihood of comping in Z, but you don't want to comp in Z. So what you don't want to do, so it knows how it comps by the way it moves. So it knows if it's left or right because G41, G42, but how you move perpendicular into the part says, oh, we're on this side of things, so.
That's 0.3134 comes in, right?
Right, so as it moves to 0.134, it turns cutter comp on.
Okay.
Now, if it was gonna go the opposite way of that, it might move to a negative 134 G42 and it would be going the other way. But we want our cutter to always stay on the left-hand side of the part.
I see why the 117s are having so much problems.
That's what, yeah, so all we're doing now is just getting the idea of some codes on there, okay? So but importance is this, is the tool needs to always be on the left-hand side of the part, right, like this. So as the tool's spinning, if you're standing on top of this tool, cutter's on the left-hand side, cutter's on the left-hand side, cutter's on the left-hand side, that's G41. Cutter's on the right-hand side, cutter's on the right-hand side, cutter's on the right-hand side, that's G42. Rarely will we G42. Only
I haven't seen a G42 yet.
on the CNC mill, conventional cutting is not conventional at all. On a manual machine, it's primarily your cutting method. We're gonna climb cut, which means your cutter is gonna stay on the left-hand side almost all the time. I don't wanna say all the time, but almost all the time. Okay, so you turn cutter comp on, you do your moves, you turn cutter comp off. Then you position over here, you got a Z move, then a G1, G41, D3, cutter compensation on again. It does its move, turns it off again. Okay, so it just does, it really does a little short.
So after the Y 1.5, X1, G64, G40, it'll be off by then, right?
After this.
Yeah, that turns it off, right?
That turns it off. Yep. So then we wrap it up to 100 thousandths above our part. Then we do a G28, G91, Z0. G28, G91, Z0 is a kind of my go-to ending codes. And you'll notice when you start the program, things really just work in chunks. They're really just chunks that are copied and pasted. Almost every one of these goes wrap it to 100, G28, G91, Z0. When you combine G28 and G91 together, they tell the spindle to go all the way up. G91 by itself says go incremental. G28 by itself says axis go home. So we're gonna do both of these two things together and we're gonna incrementally move Z all the way up. Gotta have those two codes together.
0, right?
To spindle all the way up to,
Spin all the way up, high
yep.
to go. Okay.
Yep. And another thing that you could do is you could do a G53. You could do a G49. There's a couple of different ones. G28, G91 works on all machines. Like with anything, you can make spaghetti 15 different ways.
Right.
You can CNC program probably 30 different ways. So, I mean, there are the most common ways.
And then we come back down for the tool.
So we're gonna go all the way up, then we're gonna switch back to G90. So G90 and G91 are modal commands. Modal means it stays that way until it's changed. Just like you put your car in drive, it stays in drive until you put it in reverse, right?
So it'll stay at the top as far as it'll go up until we.
It's ready for tool change.
Until do the tool change.
It's ready. On the VF3s, really on all the 3-axis machines, all the way up is at tool change level.
Really? Because I've had to go up above tool change, you have to come back down a little bit to tool change.
You can move it all the way up and then move it all the way back, or then bring it back down. Yeah, you can go past it. Okay, so since those commands are modal, if you leave it like that, it becomes incremental in your entire program from there on out. So you just go G90 right after that because it's modal. So you want to be in absolute programming. M01 is, anybody remember?
I remember what M3 is, but not M1.
M1 is optional stop. So as long as you have optional stop button pushed, it'll always stop when it sees an M1. So the idea is I ran my program through one time with optional stop on, single block, 5% rapid, everything looks good. Now I want to make 100 of these. Turn optional stop off, it will not stop between every tool change. It's going to keep going. M00 will stop every single time it sees it as M00. Okay. So,
M3 is just telling it to stop. Or
what?
not M3, M1 is just telling it to stop.
Optional stop on.
If you have optional stop on.
It's all, it's gonna just bypass
It's gonna
that
go
code.
right
and
past
keep
it.
going.
Yep. It'll only stop as an absolute stop if it has an M01 or M00.
3 lines down, the spindle's gonna just start up again at 9,000 RPMs.
Right. So if you'll look from M6 to kind of G43 on the next one on tool 2, they're the same motions as every single one. So every tool startup starts the same way. Every tool ends roughly the same way. So there's a pattern to all of it. And that's why really, when you get into the mode of programming, it's really lather, rinse, repeat. It's make the first move, make the, copy it, copy it, copy it. Now, when you do that, and I'm a big fan of copying and pasting, you've got to make sure that you are changing this H.
To make sure the tool changes, right?
Well, it'll pick up the wrong offset. It'll change tools.
Okay.
It's gonna pick up the wrong offset. If there is a number one problem that happens in copying and pasting, it is missing the H. Now, if your machine has not been altered, do you need me to help you? You got it? Good job, man.
But I have so much money.
I know, that's the process. See, mine's, look how thin mine is, man.
Right.
Yeah, yeah. My dust comes out of my wallet when you open it.
Have we heard anything on scholarships yet? At all? No. I just wondered.
We have yet to have an entire day.
Nobody asked?
Nobody said it. Yeah, I've yet to have a day this semester where no one has said. So where are we at on scholarships?
Well, we can have left, just like.
I don't know. I don't do scholarships. I don't do scholarships. So, all right. So those are the startups. Those are the ends. Okay. So now when you get to the end of this program, you see a G28 G91Z0, G28 G91Y0, and then you see,
M30 is what was M30?
that's a,
Spindle.
there's a mistake in that program. It doesn't really change anything because the next time you run the program, it corrects it.
M30 is what, how fast the spindle, or does it start the spindle?
You got that one. Yeah, yeah.
Start the spindle up again, right?
M30 does not, no.
M30 does not, so I didn't know if the zero mattered.
It says when you run graphics at the end.
M30 is not what it says. M30 found, yeah, because it's program rewind is what it is. It goes back to the beginning of the program. Okay, so if you'll notice on this program, I have failed to put a G90 in there. So what I have is this: at the end of the program, the spindle goes up, table comes towards you. So that's their individual lines. Z up, Y forward. But there's no G90 after that. So that means that program ends in incremental. So that means if you stop that program, Jacob came behind you, started his program, he would be running an incremental. But there's no way he did not, at his startup line, put a G90 in there. He wouldn't do that. That'd be foolish. See how all the startup lines, they all look the same. G0, G20, G40, G80, G90. Again, it's grabbing these chunks and lather, rinse, repeat. It just goes over and over again. This clears out any kind of G1, G2, G3, any kind of feed move that might already be in there. This makes sure that it's not in metric, in input. G40 cancels out the G41, or a G41 that might have already been left in there. G80 cancels out any can cycles, drilling cycles, boring cycles that might be in there. G90 makes it absolute programming.
Means what?
That line,
It's non-incremental. So incremental means it goes, when it sees an X1, it just goes X 1 inch from where it's at, not X 1 inch on the part. So when we program our parts, we might say this is 0. And if we say we want to go 1 inch negative, we go this way. And if we say we want to go 2 inch negative, we go here. But now if you go here and you're an incremental and you go 1 inch negative, it'll do that.
gonna do it again.
It's gonna go 2 inches from this point, not to -2. It's gonna go,
There.
Okay.
no. It will go from where it's at, 2 inches.
Okay.
So for us though, -2 inches would be just another inch from the inch, right? So you go -1, -2, -3, it would go really 1 inch, 1 inch, 1 inch. If you're in incremental, it would move 1 inch, then it would move 2 inches, then it would move 3 inches. So
Why is that?
what?
Why is it that way then?
Why is it that way?
Yeah, does it just tell the tool that's 0 then?
So like, let's just say you're doing like a grid program. And that's all your company does is make tables that have a whole bunch of tapped holes in them. And you make one program that all the holes are 1 inch apart from each other. And you make another one that all holes are 1.25 inches from each other. So when you make your second program, if you're going in absolute, you've got to change all those numbers. If you're in incremental, you change one number and you say, go 1.25 inches.
Does it keep changing?
Because it always goes from its destination and it picks up its next
New
one.
home point, I guess, right?
So I'm gonna do a quick modification. Yes.
On this, the thread cap part, when I'm running across,
Nice.
actually cutting these out, can I go across, raise up, rotate down, across, down, and back and forth cut, or should I reset every time and go cut one way?
I would go across, rotate, across.
What you're putting in there is G90?
Yep, and so if you'll notice what I'm doing now, all of my programs that I currently run, whenever I make a change to them, I will put something like revision or modified or something like that. So I'm gonna go to this program. I'm gonna say modified on 12.8. That way I know that I've got the most accurate one. Because if you already downloaded this one, I'm gonna update this one, you're gonna re-download this one. That way you've got the most current one.
Is it okay that I just followed you and saved it?
It what?
I just followed what you did and saved it?
Yeah, it's fine.
I don't feel like downloading again.
Okay. I'm gonna go pull that up.
So the probe's gonna find everything for us though on this, right?
Well,
Except for Z, or it does do Z?
don't do Z.
Do Z? Okay.
It's an odd statement to say it like that because it makes it sound like it's a magic wand.
Well, it's gonna find X, Y, and Z for us, I should say.
Well, you're going to set it to do those things. So let me say it like that. Because what I don't want you to do is to just see this as, like I say, the magic wand. Yeah, now we're good. Okay, so we're gonna look at this day video. We'll look through this one, it's like 11 minutes. And then I'll answer any questions from it. We'll kill the video then. And then There are additional videos that Haas has produced. I've got some videos on probe calibration, but right now we're just doing probe operation. So we're just gonna use the probe, okay? The probe, in the beginning, if you're just using the probe, not calibrating the probe, it's not bad. Probe calibration is a little frustrating, though.
Yeah, that's why when I redid it that one day, you're like, are you kidding me? You have to do it completely different than your regular.
Yeah, so probe calibration does take a little bit of extra time. It can be a little problematic, so. Anyways, we'll watch this, and then we'll go from there. It's gonna play the sound through my stuff.
Hello and welcome to this Haas tip of the day. Now, I'm excited about today's tip because it's all about probing.
Can you hear it okay?
In this video today, we're going to answer a few questions. I'm going to set my so what I just done
So you should go talk to Victoria. That way you don't end up with a.
video.
Go do that
All
now.
I did was jog my probe above the curve, answer a few questions, address the status of the art. And the machine did the rest. It just set my X value. So stick around. We're going to slow things down and walk through probing your parts step by step.
Anybody know what that is?
Can't do it.
Anybody know what that is?
You know?
I guess.
So it is the first Haas CNC mill. Some Haas trivia. Haas is not a CNC manufacturing company. They're a rotary company. So like the A-axis and the 5-axis rotary that we have on that one CNC, that's how they started. And Gene Haas starts making these rotaries compatible with all kinds of CNC machines out there. 3-axis was kind of primarily the only way that people were machining things. And he says, man, I think I can make these rotaries that'll be beneficial so people can do 4-axis and 5-axis machining. 5-axis simultaneous wasn't even a thing then. So then he ended up with the same problem that almost everybody has. Couldn't get parts. So he's like, okay, I'm gonna buy a couple CNC machines, I'm gonna make these parts, put them together. The guy who did all of his original electronics and stuff like that to get the first ones working still works for him today. So it's pretty awesome. And the company was started in like 1985, I think. And so this one, all of that is plastic and fiberglass. When they made their first one, it's the VF1. VF1 is the very first one. And so then the models progressed from there.
It has an actual TV monitor.
Well, it's got a monochromatic screen on it because that's what screens will look like in 1985.
Back then, that was the only screen we had. We didn't have flat screen.
I mean, I've ran machines that had a full-on CRT bubbled 1985 TV on it basically.
Did it have antennas in it?
What?
Did it have antennas on it?
Antennas, no. Might as well, like rabbit ears with aluminum foil, yeah.
Marshall, they have multiple notes that look like the Matrix, like the screen's that wide and it's black and green.
Yep, yeah. And the little cursor is the rectangle that,
Yeah.
boop, boop, and you're waiting for Neo to respond, So, yeah. So they call this one the Plastic Fantastic, just because the whole framework on it's plastic. You see these still in use today. Austin sends me pictures of them every once in a while. I mean, he doesn't work for Haas anymore, but he sends me pictures that's like, check it out. Here's another one of these VF1s out there. But it's really cool that, Haas is really the only US-based CNC manufacturer in the world. And I'm not trying to do a commercial for them. You buy whatever you want. But they found a solution to a problem. Then they came into a new problem of manufacturing, and then they're like, we think we can actually make this better. And so then they started creating their own machines. So this is in California at their at their main headquarters in, oh gosh, the name just escaped me of what the place is, where it's at. But Haas is really good about giving back to their community, so they provide all kinds of stuff for area around them.
Do you know who were they in business with? Who has been around since?
Well, so back then, it would have had to be people like G&L, and it would have been people like, yeah,
Do you need to be in G0 to rotate the A, or can you G0?
you can be in G01. Yeah, it's gonna, but you're gonna have a feed rate for it. So, like, I don't know that Herco or anybody like that was around, but people like,
But none of the Japanese company.
well, some of those Japanese companies were around, and so they were building rotaries that worked on any machine. Like, you don't have to use a Haas rotary on a Haas machine. They all plug in, like plugging into an outlet. So they all have like a 5 or 8 pin adapter that goes on the end of it, screw it in, and then you program it so that it knows what rotations are and stuff. So anyways, that's just a little trivia.
Walk through probing your parts step by step, and we'll be sure to point out some cool and perhaps little known probing tricks along the way. Here, let's talk about automation these days. And when it comes to machining, automation starts. Now, now,
Okay, so we're not talking about tools, okay? We'll also, if we can get to it, first part of next week, we'll start touching our tools off at the machine as well. So that means all you have to do is put the tools in the machine, set the approximate length of the tool. That's not the tool sticking out of the holder, that's where the tool sticks out from the gauge line. Okay, so it's not how far it sticks out from here, it's how far it sticks out from here, just like you would a normal tool. Okay, so that's what it carries, that's how it's measuring, is from here, it's from gauge line. And so all we're doing today is working on the work offsets itself. He's on a next gen control. We have next gen controls out there. You're welcome to work on any of the machines that have next gen controls on them if you want to go to that one, because that's what currently all their new videos are set for the next gen control. Classic control, or the cold start control, which is what we have for the other ones. It's almost the exact same process. You know, you're just going to go to a different page. There's 2 different ways that you can do it. There's what I consider to be an easy way, and then there's another one I think is a little bit harder to do. But the one that I think is harder to do gives some pretty good pictorial views for you to work with. I mean, it's a black and green screen that it shows the picture of what it is. Where I think the easier ways doesn't really show you the picture of it. The next gen controls, they show literal like images of the probe is here. This is the thing that you do. So very, very descriptive.
once you're on the work offset page, you're going to want to use the cursor arrows to arrow up or down to highlight the work offset you're trying to see. Or, blank. instructions are given here at the bottom of the screen. You have a 4-inch block, so I'm going to enter 2 inches. Same question for the Y. And
Two hits, hard hit, soft hit.
just like that, we're also so probing cycle approach.
I wanna watch that.
Back to that. So I need to jog my -1.2. Entered -5 inches. Now, counters display page on the main page to display this information in like where you can use it.
So if I wanted to, let's just say we always make this part, okay? And we always start with just rough stock. We always know about where they are. We can set our probing cycle into the top of our program. So when we hit cycle start, it'll always call up the probe from tool 1, always probe the part, always adjust it where it's at, and then run the part. So we never would have to ever touch off a part. Once you've done it once, it knows where it's at from there on out, and it's gonna write it to itself. So sometimes an example of that is sometimes if I'm running the robot that's on that VF3, It doesn't always place it perfectly in the where it's supposed to go, just because of just a lot of things going on. And so in one or more axis, I might come in and probe just Y or just Z. And then it adjusts the program from that point. So if the part, let's just say I'm putting parts in like this, and they might vary by 10 thousandths. I'll come in, I'll probe Y, and it'll go, oh, this part's down 10 thousandths more than the other one. Next part's up 3 thousandths more. Next part's down 12 thousandths. Next part's up 14 thousandths. It'll adjust the program continuously in Y every single time that I run that. That way I don't have to worry about having a positive stop somewhere because my robot can't grab it.
No matter what.
What's that?
Your X stays the same no matter what.
And on that particular one, my X stays the same because of the vice jaws. Now, oftentimes that's not the case because we're trying to lock it in X, Y, and Z at the same time, so we don't have to take the time to do that extra step. But if it's a part that if we always make, and there's a little bit of variation, it's a casting that has different casting heights. Or we always want to take 10 thousandths off the top of the part, but we don't care how tall the part is. So we make 14-inch tall parts and we make 2-inch tall parts, but we always do the same thing to the top of them. We just always bring in a probing cycle and it just continuously adjusts for it. So I don't have to go, well, here's some of them that are 14 and here's some of them that are 8 and here's some of them that are 9 and here's some that are 2. So I'm going to run these, then make an offset change, and then run these and make an offset change. I can run a 14, a 2, a 9, an 8, a 14, a 9, a 2, an 8. Won't make any difference.
But you're still probing them every time.
I would have to probe them every time. Yeah.
You told me to just use my edge finder and do it myself.
What's that?
And in the actual program to probe it before it starts.
Exactly. So you can take this probing cycle that it puts in MDI, and he said copy it to the clipboard, insert it into your program, save your program, and then it's just always there. So it does it by itself. And what were you saying?
To this point, I can edge find faster than that.
You can edge find just as fast as that. Yeah, it's not faster. That's what I'm saying. It's not a magic wand.
This is more accurate.
I don't know that it's more accurate. I think it's equally as accurate. It's automated is what it is. And so if I'm running 5 machines, it's way faster because I have to stand there to do the edge finding. I don't have to stand there.
You're telling Z to hover, you don't wanna go all the way down, you wanna tell it to come down.
I'm gonna start slightly above it and I'm gonna probe down to it. So let's just say I'm gonna start at about a 1/2 inch above it. And I'm gonna say I wanna go down at least 600 thousandths to hit the part. It's gonna go down till it hits the part and then do a hard hit, soft hit.
No matter what, like,
Hold it. Way off on your distance.
Yeah, so let's just say you were 5 inches from the part and you said you want to go down to 1 inch. It will never hit the part. It will go down to 1 inch and say, I didn't find a part. So it's going to error out. It's not going to keep going till it hits one. But now if you're away from the part, let's just say like he was showing you, the body of the holder was at the edge, but the probe sticking out wasn't, and it hits this area here, it will go continuously until it errors out. It will crush the probe.
It won't stop till it hits the probe, it'll hit.
Yeah, because see, it would miss the probe if the probe was sticking out there. Or, let's just say you were doing this part, and you went down through the hole. You keep going till it just doesn't know, you know? So one of those, $5,000 is what is the probe end. Yeah, just the end of it.
so if we're probing Z, and we're at a 1/2 inch above the part, to go down an inch, it'll find it and probe it.
Yeah, sure, it'll go. You can tell it, you want to tell it more.
That's what I'm saying.
But you don't have to be extravagant. You have to go 90 inches, when you're 200 thousandths above the part. You want to be like, I just want to be on the safe side. That's ludicrous to do that, So it's going to come down, hit the part,
And then just go above what it says, and then you'll touch it and go.
rough hit, finish it, is how it's going to do it. So just like a CMM would do. So, now, he touched on the VPS. There is the VPS on both classic controls and the next-gen control. And like he said, I think the offset page is the fastest way to do it too. That's how I always do it. In offsets, you go right over. Now, occasionally, you will get into a probing cycle and it gets stuck. won't come out of the probing cycle, and you'll try to go up and down and over, and you're like, man, it just won't go. If you'll hit end and then arrow left, it will knock it out of the cycle. But every semester, somebody gets stuck in that cycle, and they're like, I can't remember what to do. End, arrow to the left, it'll knock you out of the cycle. It'll knock you out. It only does it, it's got to be a right button sequence that people mistakenly do to make it happen. And I'm not sure what the sequence is. I've done it myself where I'm like, I'm not sure what to do here. But end and then arrow to the left will get you out of that cycle. So, now on the next gen controls, you can see he's got a little video of him doing the same thing that he just did. In the next gen controls, you can actually put a video in the program at the beginning of the program that says, put the part on the table, in the vise, on the dovetail, in these motions, do these things, exactly like that. So put all that stuff in there. Classic controls don't allow you to do that. They do allow you to do a lot of things. But this is just some additional features that are in the next gen controls. And so they've just got a lot. And that's part of the reason why they take so long to start up. There's a lot of computer there trying to get going. So there's stuff going on there. So 2 of the mini mills are next gens. 2 of the mini mills are classic. 1 mini mill is a classic control. 2 of them are next gen controls. And
I was like,
yeah,
Both the ones on the far end there next to the windows, right? Or
I think that both of those are next gen controls, and they're different versions of next gen controls. So some are the brand new next gen control. Some are the first iteration of the next gen control. So just like Windows computers, there's an update all the time.
Windows
So
11 to Windows 11.3.
absolutely. So we have this exact same thing. So they just told me this morning that my next UMC 500 is ready to ship. It'll have, even though we just bought those 2 750s recently, it'll have a newer control than what those have on them. But that's just like, you'll never get, I don't care, if you buy the same pen for 5 years, it will not be the same pen. There'll be always small tweaks that happen. It might get thinner, it might get heavier, it might get longer, it might get shorter. It may not be noticeable variations, it might be noticeable variations. All right, so, we'll continue on with this. Today I want you to go out and to get your stock sawed. And you've got a program. I'm gonna help you get all the tools that you need or show you where they're at.
I got my dovetail.
And
what size is their stock?
you gotta work off the part.
Oh, you're gonna give us one.
No, this is your sample. This is all you get.
Okay, so we have to measure your sample to see how.
Exactly, yeah. So you're gonna take a piece of stock. This is 1x2 stock, okay? Sorry, 1x2 stock, not 1x2 stock. But this is 1x2 stock. All I'm looking for is this to be done on the top side of it. We will then use these parts later on. The bottom sides, we want the bottom sides good. That's all we really care about. We'll take some other things. So I want you to make a few of these. Once you've, if you'll butt these up against that, if you've already done your 4 side holes in your little Lego block, you already understand how to butt the part up against the edge. I want you to keep doing that. I don't care if you make 2 or 3 or 4 or 5 of these. We'll use them next semester. And so these are just prep blocks is what they are. So lots of times your class is prepping blocks for other classes. So
That's why there's a variation.
what's that?
That's why there's a variation every now and then.
In what?
Whenever other students make parts for it, like.
Oh, totally.
Parts.
Yeah. I mean,
Not everybody's gonna do it.
most of the parts that you make are marginally, and that's just part of it, Even these guys are working on some legacy parts right now. They're gonna make 3 of them. Maybe only 1 of them's good. Maybe all 3 of them are good. And then we take those parts and we use them in our QC class, and we check those parts to see which ones are good and which ones aren't, and what happened along the way and the processes of it. So that way we don't end up throwing away every part that we make. So I'd like to have a handful of these is all I'm looking for. X0, Y0 in the middle of the part. He showed you the probing cycles and how to use them and stuff. I'm gonna take you out now and show you how to just move around in the, classic control versus the next gen control. Cause all the new videos are based upon the next gen control, not the classic control. Okay, 111s, any questions?
Can I use this one?
You can use that one.
I don't have to go buy it.